We're going to continue working through exponents by introducing the idea of a logarithm. And the logarithm is completely connected to exponents because it is simply another way to express an exponent. So we're going to be looking at exponential form, and if we have a base raised to a power, that will equal a number. Now, a logarithm is equal to the power. So the way we would express this is the log of the base n is equal to the power. And basically what the logarithm is asking is what power would take b to become an n. Before we work these problems, and really these problems are worked, we are just going to re-express them. I want to remind you of our formula. Base raised to the power is a number. And also, the log of the base n is equal to the power. So we're going to begin with the first problem by re-expressing this one. And log 3, 81 equals 4. 3, right down here, is our base. This is the number, and 4 is the power. So we want to rewrite it and say 3 to the 4th is equal to 81. So let's try the other one. And we'll take our base, which is 6, raise it to the power, and that's going to equal our number, which is 36. And these are both true statements. Now here, we're going to go the opposite direction. And we know where the base is, we know what the power is, and the number alone. So what we want to remember is this. The log of the base with n is equal to the power. So we're going to rewrite this. So we have log, our base is 5, n, the big number, is 125, and that's equal to 3. Basically what we've just said, that the power that will turn 5 into 125 is equal to 3. And then we'll do the same thing on this one. Log of our base with our number is equal to the power. Now we're going to simplify some logarithms, and what's missing is the power. So I'm going to write p in, and we'll rewrite this exponentially. So we'll have 5 to the p is equal to 25. And as we learned earlier, if the bases are the same, so the exponents are also equal. So I'm going to rewrite 25 as the base of the power. And then we have that our power is equal to 2. And that's how we simplify this. Now let's look at the same thing with log 4 of 1 over 64. So I'm going to rewrite this with my base and my power equals 1 over 64. Well, I need a common base. So 64 is the same as 4 cubed. And we need these all on the same level. So I'm going to make my exponent negative. And since I have matching bases, I can cancel them. And my power is negative 3. Okay, so our third problem, I'm going to write my p, or whatever variable you choose, and my base raised to p equals 4 times square root of 2. Now on this right side, I need to re-express this with a common base. So I will begin by saying that 4 is the same as 2 squared, and that the square root of 2 is the same as 2 to the 1/2. And what we need to do here is find a common denominator. We need to add our exponents on the right. And when you add these exponents, you get 5/2, and that is what our P is. P is equal to 5/2. Okay, let's do one more. Now I'm going to put my variable. You can use P for power or X. And I'm going to go 1/3, the whole thing, raised to the P power. And I'm going to equal that to the cube root of 81, but I'm going to go ahead and rewrite this as 81 to the 1/3. And what I want to do here is bring my 1/3 up. I want to bring that 3 up and go 3 to the -1 raised to the P power. And then I'm going to have 3 to the 4th raised to the 1/3. So that gives me 3 to the -P equals 3 to the 4/3. So that gives -3 equals 4/3, which means P, the power, is -4/3. Okay, 2 more examples. What you see with this example is that X is in the position of the n. And so as a reminder, base to the power equals n. So we'll say base to the power equals n. And this is just a matter of cubing the 4. Same thing for the next one, except this time our X is in the position of the base. We'll raise this to the 4th power, and that's equal to 81. And so we're going to 4th root both sides of this, and that will give me a 3. Last 2 examples for this lesson, and we're going to deal with fractions. So our base here is 1/2. We're raising it to the -2, and that's going to be equal to X. Well, I don't want a negative exponent, so if I flip that fraction, it'll make that exponent positive, which means X is going to be 4. And let's look at the last example. My base is 9. I'm raising it to the 3/2 power, and that's going to be X. And this can be as simple as putting it in your calculator, but if you don't have a calculator, put this back under the radical. That 2 in the denominator of your power means a square root, and then cube it. So what you'll get is 3 cubed, and 3 cubed is 27.